In this video, we'll be solving the basic equation cosine of x equals to a negative 1/2. Now this particular version of the equation leaves out the step of trying to get the trig function by itself, but in most algebraic functions, again, the first step is to always get a specific type of function by itself, be it a trig function, an absolute value function, a radical function, a quadratic or a cubic function. Well, in this case, after we've gotten the trig function all by itself, our next step is to determine, can we evaluate that function using the unit circle, or are we going to need to go ahead and utilize a calculator? In terms of the cosine of x equals to negative 1/2, the question you're going to want to ask yourself is, what angle measure can I plug in for x that will give me back a negative 1/2? Now, if this value over here is not value on the unit circle, or at least not a recognizable value based on the trig function provided, then we're going to want to at least consider a calculator. But in this case, cosine of x equals to negative 1/2 is a value on the unit circle. You'll notice that if I follow all the values up till here, cosine is always the x value. So the cosine of 2 pi over 3 provides me with a negative 1/2. You'll also notice there's more than one location where this can occur. So at the cosine of 7 pi over 6, the value, sorry, not 7 pi over 6, at 4 pi over 3, will also provide me with a negative 1/2. So in that remark, I can say that x is equal to a 2 pi over 3, as well as a 4 pi over 3. Now, these are not the only two locations that cosine of an angle measure equals to a negative 1/2. And since this says solve and it doesn't provide us a bound of values that we're allowed to pick from, we have to assume that every single value is allowed. So when I come back to my unit circle, the idea is that I can pick this location here, or I can pick this location down here. But what would you say if I started here and I went all the way to this location, and then I said, well, couldn't I just go all the way around again, providing me again I have 2, 3, 4, 5, 6, 7, 8 pi over 3. And 8 pi over 3 would be the same location as 2 pi over 3, but it is a different angle. So that means that at 2 pi over 3 I have an answer, but I also have an answer at 8 pi over 3. You'll notice one thing, that if I were to go from here to here by adding 6 pi over 3, it's like I'm adding 2 pi. And the same argument can then be said for over here. If I'm adding 6 pi over 3, again, it's just like adding 2 pi, I'm going to end up with another value that could work at 10 pi over 3. The argument can also be made in reverse, that there are negative values that should also work, meaning that if I subtracted 6 pi over 3, that I should get a value that also works. In other words, I'm going to supposedly get a value of negative 2 pi over 3 that should also satisfy this equation. And then again, if I take this 2 pi over 3 and I subtracted the 6 pi over 3, I should end up with a value that's going to work at a negative 4 pi over 3. So these are all different values that should satisfy the equation provided of cosine of x equals negative 1/2. Unfortunately, these 6 values are not the only values that will work. Given that this is a solve problem, we can solve this for any angle measure such that it is some version of 2 pi over 3 plus 2 pi or minus 2 pi, as well as 4 pi over 3 plus 2 pi or minus 2 pi. Because we can simply, on this unit circle, start at that location, that's an answer, revolve all the way around, that's another answer, revolve around again, that's another answer, and so on and so forth, infinitely many times. So for this particular equation, if I'm looking for the solution, I'm going to go ahead and write down two different versions of x. The first version of x is 2 pi over 3 plus 2 pi times k. And I'm going to note where k is an integer. And again, remember, an integer is nothing more than a whole number, positive or negative. And then I'm also going to have 4 pi over 3 plus or minus k, again, 2 pi k, where once again, k is an integer. These are the two infinitely identified solutions to the equation cosine of x is equal to negative 1/2.